this week we're going to continue with our house, and we're going to create the physics mesh. What is a physics mesh? The physics mesh could be more accurately described as a collision mesh. It's going to tell us which parts of this model is solid and which parts are hollow, you know, so we can kind of walk through a doorway but we will hit against the wall. So try to think when we talk in terms of physics in terms of collision. Now, Second Life and other virtual worlds use a system called convex hull for their physics, and I think before we go any further we need to really understand what convex hull is. So we'll just jump across to my browser here, and Wiki actually has quite a complex and mathematical explanation of convex hull, and I'll be honest with you, none of this means anything to me. So first of all, let's have a look at convex and concave. Okay, these are actually geometrical definitions. A convex is something that bulges outwards, and a concave is something that kind of bulges inwards. Okay, so within SL and other worlds we use something called convex hull. Okay, and this also applies to geometric shapes as well as kind of this kind of simple thing. Okay, so we've got two polygons here, polygon A and polygon B. Polygon A is convex because the whole thing, all of these points bulge outwards from the middle. Okay, whereas polygon B is concave because we have this point here that bulges inwards. So how does this apply to us? Well, if I jump across into Blender, you see here I've got a series of just plain circles. We're just going to think in 2 dimensions for the minute, not 3 dimensions. So I've got this series of 1, 2, 3, 4, 8 circles. Okay, and if we were trying to define a physics for this, let's just imagine for a moment that we wanted these kind of joined up. This is elements of a wall. Okay, right, so if we were trying to define a physics for this where we wanted, you know, to be able to walk in this way and collide against the wall here, or some kind of object there, okay, and we'd be able to walk in this way and collide against this object here. When we go to define our convex hull, when we go to define, and the way it is used within virtual worlds, let's first of all go with what we would be expecting. Let me just change the colour of this. Okay, what we would like to do is define a physics shape like this. Okay, so the physics actually comes and touches each point of these elements of our wall. Which all looks great and, you know, perfect. This is the kind of thing we were going for. But this is actually a concave shape because we have these elements that stretch inwards. Okay, when SL comes to define this with convex, let's go with a different colour here. Okay, what would actually happen is it will follow this to this point, but as soon as it starts to become concave, it will skip over it and it will come to this point. And same would happen here. As soon as it starts to concave, it'll come to this point. Okay, so let me just oops. grease pencil stopped working. Let me just add a new layer and make that the same colour. So the actual physics shape for this would look this way. Okay. Now there's an easy way to kind of define how convex works, and that is if we took any point in this set of geometry, okay, let's say we started here, okay, and we work around the geometry anti-clockwise, okay, so we'll be working in this direction. We've got a rule which we can kind of remember, and that rule is no right turn, okay, no right turn. So if we apply that rule and say we started at this point here, okay, if we come across from here, you see this, we are turning slightly left, and same here, if we come across from here, let's draw a tangent across here, we're going slightly left, and we come across here, we're going slightly left, we can come across here, and we still go slightly left, and come across here, and we're still going slightly left, but suddenly when we come to here we're turning right, okay, and we're not allowed to turn right, okay. So what the physics system will do is it will then ignore this point and come back to this point and reevaluate it, recalculate it. It'll come there and it'll still say we're turning right, so it'll ignore this point here, okay. Okay, so it comes back to this one and it recalculates again, okay. If it come from here up to this point, it will still see that it's got a right hand turn, which it won't do, so it ignores that as well, and it comes to the next point, which is this one here, where it continues to turn left, and the same thing will happen on this side. So what we actually end up with is this convex hull, okay. Now a hull is just another term for a geometric plane, okay, so, and this plane is convex. It bulges outwards, it cannot bulge inwards, so that basically is the definition of a convex hull.